And so we'll pivot to our next presentation, also virtual. Sarah Preston from Planet Labs, excuse me. We're going to shift topical gears just a bit and switch into some water quality topic there, and about monitoring that via near daily satellite imagery, and really getting into the water quality and climate resilience and those type of things. So I see you on screen, so I think we're ready to go. Can you hear us okay?
Hi.
Good. And we can hear you. Thanks a lot.
Perfect. Okay, let me share my screen here too. Can you see that?
Yes, we can.
Perfect. Just the presentation, not my whole mess of the desktop?
Correct.
Perfect. Okay, well, thank you all for having me. My name is Sarah Preston. I'm a product marketing manager at Planet Labs, calling in from Denver area. We're, I think, getting slated for our next round of snow dumps. So next level water monitoring, the cryosphere, I'm thinking about it a lot these days. But let's kick it off. So here's a quick agenda. So I'm just going to kind of give you an overview of Planet, who exactly we are. The point of, as part of this innovation summit, I wanted to bring water quality or general water monitoring to the table because it's something that Planet, as a satellite remote sensing company, has been looking at for some time now, but is really starting to get really deep into really the practical applications of what you can do with water monitoring from space. And then I want to give some examples of our own customers leading innovation, and then hopefully I'll have time for a Q&A afterwards. So at Planet, we are driven by this mission that no matter what your organization, your industry, your role, you can't fix what you can't see. So our mission is to provide that solution. We image the whole Earth, the Earth's landmass every day, making change visible, accessible, and actionable. Our platform is really meant to, again, make remote sensing data more accessible than ever. And the purpose really is to remove the complexity in ordering and processing satellite imagery. If you've ever used it, if you've ever played around with it, we want to really make seeing change from that broad level view easy and from the ground. So, our customers and organizations can create derived products, deliver data to their team, to those who need it most, and really enable your workforces to take action. So we are, like I said, a satellite space-based remote sensing company. We have 2 key constellations in space right now. We have more than 200 satellites of our medium resolution PlanetScope doves. These are a passive monitoring system that cover the entire Earth landmass twice daily, and at medium resolution, about 3.7 meters on average. We also have our SkySat satellites. That is a more active, on-demand tasking system. So we have more than 21 satellites in space for the SkySats at 50 centimeter orthorectified. And you can see some more of the specs there. The PlanetScopes we have just upgraded to our Super Doves, which have 8 bands, and then our SkySats are RGB, pan, and near infrared. So at a very high level, again, these are the solutions. So we have our satellites in space that are capturing imagery every day, but we do kind of more to deliver actual insights, right? So we have first our PlanetScope monitoring, that passive system that takes daily imagery of Earth. And then our SkySat tasking, which is on demand. You send an order to our SkySats, and then you receive an image of your specific area of interest. We also enhance our imagery with our base maps and archive products. So you can acquire an archive dating back to about 2009 of all of our imagery. And then we have our base maps, which is a very seamless, stitched together, broad area view of your area of interest of entire regions on a weekly, monthly basis. And then we have at a high level our analytic feeds. So looking at change detection and road and building change detection specifically, really helping to identify and call out those changes in the field. So like I said, Planet's been in the business of kind of monitoring water and water bodies for quite a bit of time. Our scientific and research community has done a really incredible amount of work on hydrology, studying our cryosphere and glacier movements, some bathymetric studies. But we're starting to introduce kind of more accessible baked products and applications that really help officials and other customers to make real decisions based on the data. So just kind of scoping the problem, I don't think any of this is kind of huge news to anyone, but of course we're entering, or we have been the last couple of decades, new world of water where droughts and floods are becoming more frequent. So that's distressing the health, the safety of whole communities, of protected habitats. Warming waters are reshaping our aquatic ecosystems, impacting fisheries and tourism. And then the demand for freshwater resources really straining all of our water resources. So this kind of call out box here by the numbers really shocked me. We have this domino effect coming where 10 billion people are expected to be in the world by 2050. Well, currently 70% of all freshwater withdrawals goes to agriculture, but we're going to have to increase the availability of that fresh water by 33% in order to meet those demands. So we're actually working also a lot on irrigation monitoring, working with agriculture companies as well to kind of keep check and develop new ways of like monitoring their consumption, that kind of thing. So this is just a highlighted case study that we did recently as well about the California drought. Of course, we're still in the West, this kind of big mega drought. But what we did, this was soon after Governor Gavin Newsom, he had declared a state of emergency in the Russian River watershed back in April of last year. And so what we did here is with our broad area monitoring, we took a whole map of the watershed and we took the NDVI measure of vegetation there to over the span of that year. So May 2020 through May 2021, to really visualize the change over the past year in the drought conditions. And so you'll see here the orange areas have experienced the most change, the largest difference over that year. So they're very dry. A lot of them stem from recent wildfires. And then the bluer, lighter areas are areas have experienced maybe a little less change. But we really wanted to kind of map this out, visualize it. Again, this is our near daily monitoring constellation that can provide this type of information with layers that you can put on top to really measure that change. So I want to dive into a little bit more of these use cases. This is some before and after imagery we took December 2020 and January 18, 2021 of the Upper Klamath National Wildlife Refuge in Oregon. So in 2020, on the left, this portion of the refuge, you can see this grid of drainage channels, which appears flooded by dark water from the adjacent lake. And then in 2021, you can see those same drainage channels and where the water levels appear lower, likely the result of sustained drainage in the area. So what we're looking at here is, again, Planet's frequent daily imagery monitoring plus our high resolution solution that provides these type of views of the change in water levels over a specified period of time, that we can kind of keep an eye on that. What's interesting is because our imagery is close to this near daily cadence, we can actually pick pretty close to extreme, like 1 year, almost exactly, of a difference in measuring. So it allows, again, it allows kind of this, you can measure very specifically if you want to do as close to a month as possible, or 6 months or a year, that kind of thing. This is another example that in Oregon, actually, of how some of our high frequency satellite imagery helps in water resource management, especially for conservation efforts. So this is a false color PlanetScope image, so our medium resolution, about 3.7 meters. It shows the Slough Reserve in Coos Bay in Oregon. So this is actually at low tide on April 13, 2020. And what we've done here is overlaid actually the distribution of eelgrass in the reserve. So you'll see these kind of white outlines along the river. And what this helps is really tracking key, specifically in this use case, key eelgrass habitats that support coastal fishing communities. So there's been kind of this slow disappearance that they're still kind of investigating, but at a high level, you're looking at a way that we can track the productivity of marine ecosystems that support, local fisheries. And it's a lot of times seeing these broader area views are difficult with aerial imagery. They can be cost prohibitive. It can take a while to sometimes get that imagery back. But this is something, again, we can track on basically a weekly or monthly basis. And we have an archive that you can go back in time and see that, measure that change. This is, can you see hopefully the video moving? This is actually a video kind of speaking to this conservation angle again, identifying vegetation within water bodies. So if I can catch up, what you're seeing is a visualization of a lake in Louisiana. We processed here a false color infrared in some ENVI image processing software. And then what we did is we kind of dug deeper, and you can see these changes in vegetation. It's specifically called Slovenia. It's an invasive aquatic plant native to South America. And we're able to perform this analysis on some of our 4-band data that helps you see, I don't know if I can play it again, but helps you see some of the difference in aquatic vegetation and how it's grown and changed. So PlanetScope imagery has really enabled this kind of aquatic plant tracking, being able to see it with some analysis on top. So we've been able to do this. You can measure Slovenia volume. You can proactively use this to take measures to, again, kind of monitor the spread, but also target mitigation efforts. So this kind of speaks to, this is something you can do at a much higher frequency that we found with satellite data. Again, kind of mixed with or compared to maybe some aerial that takes some time to get back. Moving into flooding. So this here is before and after time series of late fall of last year in Linden, Washington. So this here is the Nooksack River. And what you can see at a very high level is some extreme flooding that they experienced, again, fall of last year. So something like more than 300 people were displaced. Several dozen properties and homes were destroyed. And it wasn't until kind of later that November that I think officials really came together to quantify that damage. Well, this is just in the span of after the flooding, a week or so, that we were able to see the extent. So how far, October 31st, 2021, this is a look at kind of standard normal conditions. And then November 16, this was the look at post-flood. So we find that officials, it takes some time. They might not be able to take a closer look at specific areas right after a disaster or an emergency. So in this imagery, you can kind of see the areas where conditions might be worse, where you need to dispatch resources sooner because it's hit those places harder. So we found that this is somewhat interesting for again, disaster assistance programs to help locals kind of apply for those and then to validate those applications and for insurance payouts as well. I wanted to go into another kind of flooding example to really highlight something that we call tip and cue, that you can do the combination of both our near daily PlanetScope monitoring solution and then our high-res on-demand tasking solution. So here is another flooding event back in winter of last year. or February into March of Red River flooding in Kentucky. And so this was another extreme event. I think flooding had reached some 20 feet in some areas of that county. And you can see again that before and after imagery really only maybe a little bit more week apart from standard conditions versus post-flood. But what we've been able to do here is take that second image, and what we do is you actually can use our SkySats then to take a deeper look. So this is another area, part of the river, using our high resolution SkySat, in which you can see some of the flooding receding. So what some of our kind of customers and partners will do, if I go back to this, is they'll use our daily monitoring. They'll go into our platform and kind of check out at medium resolution where the issues might be from a very high level. And then once they find an area that they want to zoom in on, they get a tip as to some area of concern or key change. They can place a high resolution order to task a satellite to take a closer look at 50 centimeters. So it's a very responsive solution. It's a lot of times, right now, governments and organizations, they do this kind of already, but in different ways. Like they'll use our imagery, but instead of maybe tasking a satellite, they'll dispatch their response teams to that area to take a closer look. But for really remote areas or something you need really quick, this has proven to be actually pretty valuable. So here again, you can see we don't have a before SkySat high-res image, but some of the water has been receding. There's a little bit of recovery. It's a good chance and opportunity for officials to go in and really quantify and measure some of that damage. And then this is moving a little bit into water quality. So I realize I'm covering a lot right now, but here is some imagery actually of an oil spill off the coast of Peru, again with our medium resolution planetoscope imagery. So the story here is that there were giant tsunami waves from the Hunga-Tonga eruption that rocked a tanker unloading quite a bit of oil at a refinery near this coast. It was roughly, I think, 6,000 barrels of crude oil and it spilled somewhat. It's like 6,400 miles away from the shore, but it came in. What we were to see through this imagery is how it came in actually to the shore and how it spread and spilled along the coast. So you can see here, there's this kind of on the right side in January, there was normal conditions in December, and then on the right side in January, you can see that sheen that is kind of a visual look at the extent of the oil spill. So it's a good indicator again of like poor water quality, where exactly the hardest hit areas are, and really looking at kind of the scope of the problem. So then something before I go into the next use case on water quality I want to highlight is on this innovation front, something newer that Planet's been able to delve into is with our recent super dove imagery. So we now have our broad constellation, has a lot of traditionally 4 or 5 band imagery, but now with our most recent super dove that we have in orbit, we have 8 bands. So that was our standard RGB, near infrared, but then we've also added coastal blue, red edge, yellow, and a second green band. So we now have at this daily resolution or temporal frequency, we have this 3.7 meter resolution, 8-band imagery, harmonized now to Sentinel-2 that is giving us a little bit more detail about water on some of these water use cases. So for example, one of the things that we've been able to do pretty well with this 8-band data is measure vegetation within water bodies. And specifically, what you're looking at here is a chlorophyll index. So this is chlorophyll, well, to be very high level in general, the chlorophyll index is a measurement that's sensitive to the presence of chlorophyll A, which can be a big indicator of harmful algal blooms and an increase in other vegetation within water bodies. So this here is Lake George in Uganda. The values, as you can see, that are in darker blue while higher level values are in green and yellow. So you can see there's kind of these, so smaller lakes to the south at the below do have these elevated chlorophyll levels in addition to some other areas on the East Coast there. So that indicates kind of poor water quality. On the front of monitoring harmful algae blooms, it really helps, again, kind of scope the level of issue, especially in large water bodies. And at a near daily cadence with this 8-band, you're able to take a bit more quantitative measurements, like with this maximum chlorophyll index, again, as to like the extent of the issue. So that's very high level, some of the work Planet has done broadly on water monitoring. It's a lot of use cases to cover. It's very broad. So what I wanted to dive deeper is to, really highlighting some of our customers and partners that are leading some of this innovation, actually. So first, I wanted to cover the government of New South Wales in Australia. So they are looking a lot at permitting and water use infractions. They are very similarly going through pretty extensive drought, and they've also experienced pretty extensive floods. So they have these kind of water extremes that they're working with in a state that is very heavily agriculture. So one thing they're really trying to do is monitor water intake, because they frequently have to adjust policy based on flooding, based on drought, as to how much water that agricultural companies, agricultural fields can take in. So these water planning experts at the Department of Planning, Industry and Environment, they monitor thousands of on-farm storages across their state and across their region. So they have to track the water storage capacity in these thousands of storages. So again, with compelling events such as drought and floods, they have a measure of how much water is available. So for the most kind of up-to-date information to follow the disasters and the conditions that are pretty commonly changing, they really found value in having this daily imagery to take, and reliable, right? So you can take months, pretty close to months or 6 months at around the same time for standard like time series. So they were able to use, access our newer imagery, but then also go back in time with our archive imagery as soon as they signed up for a subscription to kind of track the change, so that can influence their policy decision making. Do we have enough water to enable our agriculture industry to take in more water, or do we need to put even more restrictions out there? Let's see. This here, I wanted to zero in on a PlanetScope image. This is the same use case as the Department of Planning Industry with New South Wales. But what they've done here is taken the PlanetScope image, specifically they found of a water storage pump near a river in the region. And I wanted to kind of point out just some of the detail that you can see before I get into how really they monitor and quantify water levels in these storages. So you can see, hopefully, the tiny little arrows, they are right there. That's kind of identifying where the storage intakes from the river, and then how it feeds into the larger reservoir, the storage tank. So in the past, it was kind of difficult for them to monitor this type of infrastructure they had used Landsat, Sentinel, some other open data sources before, but it was just harder from the resolution, from kind of the infrequent cadence to really get a good sense of what it looked like. So they've been able to much easier actually kind of point out these features for either inspection or just to have a general sense of what's going on the ground. And this is more specifically what they had been able to do. So they really do quantitatively measure the surface area of some of these on-farm storages to get a sense of how much water is being taken in and used. So they first use, Planet is a very complementary source. There's a lot of synthesis with using Landsat Sentinel, but then also using aerial and LiDAR imagery. And here they did use LiDAR. So they use elevation data from LiDAR to take kind of initial measurements of the storages. And then they verify that change with PlanetScope imagery. So they can do LiDAR surveys maybe once a year, once every 2 years to get an updated sense of how big those storages are, but they really need to see more frequent change. So they use PlanetScope imagery to dive in at a more frequent cadence. So you can see here, there was this big flood event. And so they were monitoring the surface area change over time to see when they could lift or when they might have to start replacing restrictions on water intake. So they had monitored about 1,500 storages during a flood event in 2021 here. You can see the time series. And with using that LiDAR data, they noticed that storage capacity had gone from about 16 to 52%. And that was a significant change for them to note over the course of that event, that the capacity had increased and they were able to make more policy decisions from there. Diving into another use case. So this is a partner who's doing some very interesting work for us. They're called EOMAP, and they do a lot of services with governments looking at water quality. And this here is on the left, a PlanetScope image of the Largia Reservoir in Italy. And so what they were doing is they were working with the local water authority there to track water quality in the reservoir. It's a source of drinking water for more than 700,000 people in the area, and a keynote of concern, especially from the drinking water piece. So the goal here was, a biggest area of concern was, again, measuring harmful algae bloom outbreaks and this chlorophyll A. So they wanted to also measure here the turbidity, which is another word for kind of the clarity of the water. So measuring particulate in the water, getting a sense of how clear it might be. And they performed their own kind of analysis here to actually come up with a dashboard that shows, again, that change in water quality levels. So at this point, the government of the water authority in Italy and Sardinia was using this to, again, kind of measure when they might need to tap into water reserves from cleaner sources, and then when they can tap into this just based on the water quality. So they were doing a lot more interesting work actually on this front as well that we're excited to come out with later this year, using our 8-band data to more quantitatively measure these water quality issues. And the trick here too was this reservoir was so big, so broad, and in a somewhat remote area that it was really difficult to get that kind of high level view. So EOMAP, our partner, was able to take our imagery and dive deeper with their analysis and capture a whole view of the reservoir. One other thing I wanted to cover here is that Planet's diving deeper into these water use cases now, that we have this incredible data to offer. And what a lot of our customers are taking advantage of now too is these professional services offerings. So what we really want to do is we don't want to make this data hard to incorporate into your workflow. The point is not to be a complete change to upend everything our customers are doing, but to really easily integrate some of the imagery, especially if teams have never used it before, into their workflows to complement existing data that they have or to augment it. So like I mentioned, the government of New South Wales, they're using other data sets, they're using LiDAR, but they just needed a more frequent view of what was happening in order to make more real-time policy decisions. So they augmented their data set with PlanetScope. So the reason I bring up professional services here is because we have a whole team that's kind of dedicated to this mission to really amplify, augment these workflows with training, with a full launch program to get our partners and to get our customers kind of up and running as soon as possible. And then that's actually about it. So thank you. I wanted to flash up my contact information here. Also, my colleague, Andrew, I think he's at the conference and should be on the line, but his contact information is here. I feel like I brushed through a lot in the span of time. So if you have any questions, feel free to reach out and I can either try and answer what I can here, or we can dive deeper after the conference. And then I think I'll take questions. I'll try and dig up the chat.
Yeah, thank you, Sarah. I didn't see if there was anything in the chat before I walked away from my screen. Jamie, is there anything there?
Hi, Jonathan. I don't see anything at the moment.
Okay, thank you.
Wow, that was all perfectly clear and obvious.
That's the product of an excellent presentation. I think we have one in the room.
Thanks, Sarah. Frank Winters from New York. All right, so let's get that under control. It's not me.
It's not on my end, isn't it?
No, that's me. Sorry about that. All right, I'm interested in folks using the temporal resolution to really refine the optimal time. There's a lot of phenomena that we want to measure that has very specific temporal slices. So you capture the algae bloom on the day it's blooming. But I'm also interested in how that feeds into machine learning and AI algorithms. So I think that might be something that you have experienced potentially.
Yeah, so I guess I'll refer back to, we have a pretty extensive network of partners that are doing a lot of that machine learning work on our data. So, and again, one thing we've done is we've actually kind of harmonized our newest set of super doves to Sentinel-2 to create this more common workflow that we're finding. And our partners are developing some really interesting solutions. I can't say that we can on day one detect a harmful algae bloom outbreak, but what a lot of our customers will do is they'll kind of detect the onset, or they'll get their early indicators from some of the solutions of our partners as to when an outbreak might come or how it's expanding and growing. So if you're interested, or if anyone's interested in learning more about that kind of machine learning piece or those derivative products, I'm happy to get you in touch with one of our partners and our partner network who are doing really interesting things there.
So hi, Sarah, this is Cy Smith from Oregon. There were a couple of things to mention, I think, that I didn't hear you mention, although it's possible I might have missed it, about we did some pilot testing in Oregon with a number of different state agencies. One thing to mention is that we found a great opportunity to compare planet imagery to our existing aerial imagery that was flown a few months before, maybe a year before, something like that in different areas. That helped us see some changes that we might not have otherwise been aware of, and we needed to. From a regulatory standpoint, there were agencies that needed to be able to compare imagery from a year ago that we had with imagery that we were getting, that you all could provide in this pilot on a regular basis over several days. And then the other thing that we found that was useful was with regard to mineral extraction. And there's a lot of mineral extraction that goes on all over Oregon, very large state. 2 or 3 people that are responsible for monitoring that could not get to all of that stuff that was happening, and much of it was not permitted. So they were able to look at these things and see just over a short span of a few days by looking at the planet imagery, whether or not there were things happening out there that allowed them to target their travel to specific places, as opposed to just a sort of a shotgun approach of going across the state and just trying to hit everything over a longer period of time. So it saved a lot of money for them in that sense. So I just wanted to throw those two things out there that I was reminded of as you were going through the presentation. Thank you.
Yeah, thank you. I mean, really, so the value here of this is, especially what you're referring to, is our PlanetScope constellation, which has this really high frequent monitoring. And it really helps with those broad remote areas. So we're very, like I mentioned before, very on that first use case complementary to aerial, where, you know, it has some higher resolution mapping, but because we have it on this near daily, weekly basis, you can really get updates when you need it. Even just for visual inspection or at a high level. And then you can also use this PlanetScope, to your point, you know, before sending anybody out into the field, any kind of inspections, you can see, is there a potential violation? Do we need to send anybody out there? You can kind of scope the problem at a high level first.
Hi, this is Leslie from Alaska. We had a pilot with Planet last year, and it was wonderful. Similar to what Sai said, we found a lot of value in monitoring mines remotely for regulatory enforcement. Also, it's, you know, Alaska is huge and it's hard to get places, you know, we fly everywhere. So I think one of the biggest things we saw was using it to increase efficiency in government operations and saving money. Where we typically stage aircraft to fly over, like for monitoring wildfire sites, trying to find those snow-free days, and you know, doing that all across Alaska. You know, things that typically take months of planning and time, we did in like 2.5 hours, not leaving our computer. So we have found in Alaska, just because of the remote nature, a lot of benefits from that technology.
That's great to hear. And also, I mean, on another remote level, we're finding that organizations, because we're in this remote work environment, have found that it's kind of useful for shifting workforces, again, not having to send people necessarily out into the field if they don't need to go, or if they just can't go. But yeah, it's great to hear, Leslie.
Any other questions or comments in the room? Jamie, not near a screen, so. Oh,
Thanks, Karen, for coming off mute.
I'm busy eating my salad, my customary salad. So thank you, Sarah. It's very interesting. And I have one question for you and then one question for both Sai and Leslie. So Sarah, for you first, I assume that your pricing model is based on the geographic extent for that medium resolution.
Yeah. Mm-hmm. So we do have, so kind of on area, and then, but we do have a an actual just up-to-date GSA schedule as well. So we, that's public to view also.
Okay. And then for Sai and Leslie, I would be very interested to get access to any written reports that you have or summaries of those cost savings using the imagery to find those, you know, monitoring of extractive resources, because that's certainly what we deal with in Wyoming. So thanks.
Yeah, this is Leslie. Karen, yeah, we actually, it was part of the pilot that one of the outcomes would be a white paper for Alaska. And so we're actually finishing that up with Planet right now. And it goes through all of our use cases that we evaluated it for across departments. It also, because we just realized in the pilot, we weren't actually able to reach all the use cases that we knew existed. And plus it's hard to get people to adopt new things, a new way of doing things. And so the paper will also hit on where I see potential additional use cases. And it's hard to quantify the ROI, you know, like monetarily, but we do it with words.
And we did put together a report, Karen, with Planet's help, that's got a lot of good graphics in it, and you know, copies of the imagery, not copies, but pictures of the imagery and things like that, with the intent of justifying you know, an ongoing investment, which didn't end up working out because I was trying to put money together into a pot from a lot of different agencies that, you know, has its challenges. But But regardless, it was a really good report that I thought justified the investment.
Any other questions or comments? We've still got a couple of mics floating around. But if not, Sarah, we certainly appreciate your presentation here today and your participation with us.